So hello everyone. We'll take the same example, and as you can see, we already have calculated these columns. Okay, xi minus x bar square, xi minus x bar cube, and xi minus x bar raised to power 4. And we have also calculated their sums, right? So we have to do nothing else but simply divide these sum values by n, that is 7. Okay, so for example, m1 is 0. Okay, m1 is clearly 0. M2 is 122 divided by 7, whatever value this is. M3 is 120 divided by 7, and M4 is 2786 divided by 7. Now, regarding its interpretation, now if you must have observed or related with the formula of skewness and kurtosis, the population skewness, population skewness is simply equal to M3 divided by sigma cube, right? And population kurtosis is simply equal to M4 divided by sigma raised to 4. Or you can also say that is M4 divided by variance squared. Okay. So therefore, whatever interpretations we studied for skewness and kurtosis also apply for M3 and M4. And related to M1, I already discussed in the previous video. M1 will always be 0. Interpretation is that because we are not taking the absolute value, or what, we are not squaring the differences of the data points from the mean. Okay, if we keep the positive and negative differences of different data points from the mean as it is, and we add those differences, ultimately all those differences will sum up to 0. So that is M1, why it is 0. For M2, it is nothing but your standard deviation, assuming it's a population. Okay, so you can simply say that it gives us an estimate of the spread or the dispersion in our data. Kurtosis, skewness gives us an idea about the symmetry of the tails, whether one tail of the distribution is longer than the other. And kurtosis, the interpretation is either the fatness of the tails are either normal, as in normal distribution, or the tails are thicker and the peak is flatter or peak is lower in case of platykurtic, or the tails are thinner and the peak is taller, as is the case in case of leptokurtic distributions. Okay, so that's it for the calculation and interpretation of central moments. Fun fact: so this skewness and kurtosis, when we divide, okay, when we divide the central moments by the standard deviation, then they are called as standardized moments. So you can say that skewness is the third standardized moment, kurtosis is the fourth standardized moment. We also have first standardized moment, which is m1 divided by sigma, which is obviously 0. We also have second standardized moment, which is m2 divided by sigma square. Now m2 itself is sigma square, or you can say variance. So therefore, this will be equal to 1. M2 is variance, square root of M2 is standard deviation, right? So that's it for this video. If you have any questions, any doubts, do post them in the comments below.